Hi fans, welcome back to my channel. Thank you for always staying true. Today's class is very important and I want you to stay back. Make sure you participate actively and you watch through the end. Now what do we have for today? Our topic for today is on differentiation. And what do we mean by differentiation? Differentiation simply means rate of change. It can be rate of change of one variable to the other. Let's take for instance when we have rate of change of y and x. If we have rate of change of y and x, we call it dy dx. If you have rate of change of s and t, which is a function of time, we call it ds dt. Now, there are other words we can use for the differentiation. You can call it derivative, you can call it differential coefficient, you can call it gradient, because gradient at a point is the same as differentiation. Now, these are words we can use in place of differentiation. Now, let's take it to the board. Supposing we are given y as a function of x, and in this, we are asked to find the differentiation. Its differentiation, if you are differentiating this, we call it, remember y is a function of x, we call it dy dx. You can also call it f of x. This is showing differentiation of this function. You can also represent it like this. You can also represent it like this. These are ways you can represent differentiation. Okay? This one means you are differentiating to the first order. This is also first, and we shall look at other orders of differentiation as we progress. Okay, now that we have understood what we meant by differentiation as simply rate of change, now we want to look at how to differentiate using the general formula. And when do we use the general formula? We use general formula on simple polynomial. Now let's look at this. Supposing we are giving example, but before then let's introduce the general formula. Now for the general formula, if y is given as a function of x, I hope you are there, then dy dx, let's take it that this is the same as x raised to power n from the general formula. Then dy dx will give us, you use the power to multiply, and in that case you have n times x, then you subtract 1 from the power, you have n minus 1. So each time you are using general formula, this is what you do. When you have a function, what you do is make sure the function is in index form. So when it is index form, use the index to multiply the function, then subtract 1 from the power. This is what we meant by general formula. Now we're going to use this technique to answer so many questions we have on differentiation. Okay, now let's take examples on this. Remember, y is xn raised to power n, then dy dx is nx raised to power n minus 1. Now let's look at examples. We have, let's take y to be 3x squared plus 2x minus 5. We are asked to find the derivative of x. Now when you have this question, if you look at it, you can easily use general formula. How and why? If you look at this expression, you see that this is simple polynomial. So this is 3x squared and is a simple polynomial. And if it's simple polynomial, which has the powers, x has, each of these x has powers. So you can simply use general formula in this kind of question. So let's now see how to differentiate using the same general formula. It's very interesting, just pay attention. Now what we are going to do here is, since this is a function of y and x, we have solution. Here we are going to have, this is a function of y and x, we call it dy dx. I hope you are following. Then, what do we do here? We're going to use this power to multiply the coefficient. We have 2 times 3. Then we have x, subtract 1 from this power, we have 2 minus 1. Plus, this already has power 1, according to your index. We are going to use this one to multiply 2. So we have 2 times 1. Then we have x subtract 1 from the power according to the rule. Then we have minus 5. 5 is the same as 5. We have 5 is same thing as 5x raised to power 0. If you remember your indices, where x raised to power 0 is 1. So we can now say that 5x raised to power 0 is the same as 5. Why we are forcing this 5 to be 5x raised to power 0 is to give x a power with which we are going to multiply 5 with according to our rule. So let's take it that this 5 is 5x raised to power 0. So we use this 0 to multiply 5, and that will give us 0 times 5. Then we have x 0 minus 1. I hope it's clear. Let's take that again. Use 2 to multiply 3. We have 2 times 3. Then x, subtract 1 from 2. Plus, use 1 to multiply 2. We have 2 times 1. X, subtract 1 from 1. Minus 5 is a constant, but we are forcing it to be a variable. So in that case, we have 5x raised to power 0. Use 0 to multiply 5. Then subtract 1 from 0. So in that case, we are going to have 2 times 3 will give us 6x. 2 minus 1 is 1. Then we have plus 2 times 1 will give us 2. Then we have x. 1 minus 1 is 0. When you use 0 to multiply everything here, it will give us 0. So what do we have next? We have 6x raised to power 1 is 6x plus x raised to power 0 is 1. And 2 times 1 will give us 2. So we are done differentiating. This is our answer. What does this simply mean? We can simply do it this way without going through this. Simply use 2 to multiply 3, we have 6x. Then use 1 to multiply 2, we have 2x raised to power 0, which is just 2. Now what this means is, whenever you differentiate a constant, you see there's no longer 5 here. Whenever you differentiate a constant, it is given as what? 0. Now, constants you can have if you differentiate 5, 0, if you differentiate 20, 0, if you differentiate 10, 0. So anytime you have a constant, whenever you are differentiating it, it gives us 0. Now, in this, we have 2x. Each time you are differentiating a number like 2x, 5x, 10x, 100x, 20x, it gives you that number, the coefficient. So if I'm differentiating 2x, it is 2. If I'm differentiating 100x, it is 100. If I'm differentiating minus 10x, it is minus 10. So these are some secrets I want you to know to reduce the stress of differentiation. Okay, now let's look at, remember, to subscribe us, like, share, and comment. We have a lot to unleash. So by subscribing, you get to know more. Each time we release any of our trending video on any of our teachings, you get to know about them. Be the first to know about them. So always subscribe, like, share, and comment. So let's look at example 2. We have y is 3x raised to power 4 plus 2x squared minus 1 over 2x squared. Can I use general formula in this question? Because as I'm looking at it, it is in a fractional form. This is a rational expression. Now, if you want to use general formula on this question, what you simply do is, you are going to reduce this expression to be in index form. Index form I mean is, make sure that this expression is simplified, in the sense that there will no longer be a denominator. I don't know if you understood what I meant. This is a rational expression. I cannot just use this formula on this as it is this way. No. You have to first of all simplify it so that this denominator will be eliminated. Then when you do that, you can now use the formula method. Remember, it is y equal to x raised to power n, not y equal to x raised to power n over anything. No, it has to be a straight expression without a what? A denominator. So that is the one thing I want you to know about. So what we do here is, we are going to simplify this. Now in simplifying it, we have, let's do it here, we have y is 3x raised to power 4 plus 2x squared minus 1 all over 2x squared. So what we are going to do here, we divide each term by this denominator so that we remove the denominator. So we have y is equal to 3x raised to power 4 over 2x squared plus 2x squared over 2x squared minus 1 over 2x squared. So you see, we simplified more. Remember, this is in an index form. According to your indices, these two will come over to be minus 2. So we now have y is 3 over 2x. When you subtract 2 from 4, we have x raised to power 2. So we have simplified this. We have plus 2x squared over 2x squared is 1. Please remember, when you divide a number by itself is 1. Some students will just come and put 0 here. No, it is 1 because you are dividing this by this. When this divides itself 1, if you divide this 1, so 1 over 1 is 1. I hope that one is cleared. Then we have minus. This is 1 over 2x squared. How do we force this to be in index form? Remember, if you have 1 over 2x squared, is the same thing as 1 over 2 times 1 over x squared. I hope you are following. So in that case, you have 1 over 2. According to your indices, 1 over x squared is the same thing as x raised to power minus 2. So for simplifying this, we are going to have 1 over 2 x raised to power minus 2. I hope that one was cleared. Okay, now we can now differentiate at this point because we are having a straight expression, no longer denominator, then we can use the general formula. So let's do it together. We have dy dx at this point. Remember, use the power to multiply, subtract 1 from the power. 2 we multiply this, so we have 2 times 3 over 2. Then x raised to power 2 minus 1 plus, from our last example, remember we said this is a constant. So when we differentiate a constant, it will give us 0. So I will simply put 0 here. Then we have minus 1 over 2. Remember, I am using this power to multiply this. So I will have times minus 2. Then we have x minus 2. I will subtract 1, it will give me minus 1. So let's simplify this. You have these two, we cancel these two. We have 3x, 2 minus 1 will give us 1. So x raised to power 1 is just x. Plus 0. Then minus half times minus 2. Minus we cancel minus to give us plus. Then 2 we cancel itself to give us 1. So we're going to have x minus 2 minus 1 will give us minus 3. This is our dy dx. But remember the question says, find this dy dx at when x is equal to 1 over 2. So what you are going to do at this point is to substitute the value of x to this particular function. Please, let's take it to the other part of the board. So if we are substituting, we have dy dx is equal to, remember this is 3x, so we have 3, our x is half, plus our x there will now be 1 over 2 raised to power minus 3. So remember this is 3 over 1, and 3 times 1 will give us 3, so we have 3 over 2 plus, this is 1 over 2 raised to power minus 3. Let's simplify it using our indices. When we have 1 over 2, according to indices, this negative sign will turn to reciprocal. So it will be 1 over, this minus will be 1 over. Then we have 1 over 2 raised to power this 3. I hope you are there. So if we reverse it, because of this one, 2 will come up. So in that case, we are going to have 2 over 1 raised to power 3. And what is 2 raised to power 3? 2 raised to power 3 will give us 8. So when we simplify this, we are going to have 8. So 3 over 2 plus 8 will give us, this is 3 over 2 plus 8 over 1. Use these two to multiply 8, it gives us 16. Then 16 plus 3 will give us 19. So we are going to have 19 over 2. So our answer for this question is 19 over 2. If you want to simplify further, you are going to have, please let's take it up here. 19 over 2 will give us 9.5. If you can leave it this way, 9.5, or you can also say 9 whole number 1 over 2. All these answers are correct. Please, if you found what we did interesting, remember to like us, share, and subscribe.